Welcome to Mac 2311 for engineers. This is exam 2, problem number 11. So in this problem, they go ahead and they say that they give you this function. It represents a spring oscillating back and forth. And they go ahead and they ask you, what is the velocity and acceleration when t is equal to pi? So first we should go ahead and take the first and second derivatives and then plug the pi in and get our answers. So what we can do is, we know that derivative of sine is cosine, derivative of cosine is negative sine. So this would be cosine 2t times 2, that's a chain rule, multiplied by the derivative of the inside. And this would be plus sine t, because we know the derivative of cosine takes us to negative sign, so the double negative goes as a positive. And there's nothing on the inside, so it's just a t. And the derivative of t just goes to 1. Now let's take the derivative of this to get acceleration. This 2 just hangs out front. The cosine of 2t is going to become negative sine of 2t times 2. Once again, another chain rule. Plus cosine of t. The derivative of sine just goes to cosine. And the derivative of 1 goes to 0. So that's our velocity, that's our acceleration. Now let's go ahead and feed the pi in. The velocity at pi seconds is going to be, well, this is going to be 2 pi, and cosine of 2 pi is equal to 1. You have to just recall your unit circle. So this is going to be 1 times 2, so that's just going to be a 2, plus, and then sine at pi is going to be equal to 0, so that's just going to be a 0 there, and then plus 1. So 2 plus 1 is just going to be 3. So your velocity will be 3. Now we can do the same for the acceleration at pi. So 2 times 2 is just going to give you 4 times, and then we can plug in pi here. 2 pi, sine at 2 pi is going to be equal to 0. So this whole thing actually just goes to 0. Plus, and then cosine at pi. And cosine at pi is actually just going to be equal to negative 1. So then this is just 0 plus negative 1 equals negative 1. So that gives you a speed of 3 but an acceleration of negative 1. And that's your final answer.